Let's talk about Printf for a few minutes here, shall we? Printf is short for print formatted, and we've already used it a few times, and now we're going to find out what all those interesting little percent characters are in the format string that we've been using. Printf takes in a string, which is called the format, and then it needs as many variables to fill in the data in the format string as the format requests. So let's look down here. Here's printf, and there's a double quotes, and there's a double quote. So that's the beginning of our string. Now this string could have been defined someplace else in our program, and it can even be dynamic. You can create this thing as you go through your code. It's just a string, like any other string in C. So this string, or a pointer to a string, gets passed into printf. Then a comma operator, and then we have to have variables, or in this case another string constant. We have to have enough of these to satisfy the replacement characters, the conversion specifications is what they're called, over here. So here we have 3 percents. We have a %C, which is a character, and so we'll pass in a character that we've defined earlier, a C. Here we have a %D, which is going to be a decimal, and that's just an integer I that was created someplace up in our program. And here we have a %S, and that's for a string. And then our old escape sequence we talked about a long time ago, this one is our new line escape sequence. And here, since we have a %S, we need to have a string pointer. Now these have to be in the very same order as they're used over here in the format string. It's 1 for 1, and it's undefined what happens if you don't have enough of these items to match up 1 for 1. It's undefined what the compiler is going to do because it's going to go looking for things that aren't there. So that's a bad thing. If you pass too many items, it doesn't really matter because printf won't see the other ones that are out here on the end. It will pass them into printf, but it won't use them because it uses them in order, and it would ignore anything out here on the end. Here's some of the, or actually all of the conversion specs are coming up in a table, but this is how a conversion specification is built. First of all, you have the %. The next thing that you may have after the %, if you want to, and if you are going to use the dash, it has to be right here after the %. That means left justified. If you have the % like down here, 3.3s, we'll see what that means in a minute. If we were going to left justify that string into its field, there'd have to be the dash right here, the hyphen, to mean left justified. It has to come right after the %. Now, that's fine if you used it or if you didn't. Either way, the next character that could be here is a number. And I just have the little hash mark here to show you that this would be a number, 0 through 9, and actually even a larger number than that, because this is a total field width. This is how wide the field will be that this item over here will be printed in. So the first number is the total field width. Then if there's another one, there will be a dot between them. We'll have a dot, and then the precision. Now the precision means different things to different kinds of variables being passed in here, different kinds of values. If it's on a %S, then that's the maximum characters of a string to be printed. So here we have %3.3s. So what I'm saying there is that in a field 3 characters wide, you can put a string of up to 3 characters long. So if you made this, say, 10.3, you'd have a field 10 characters wide, and the last 3 of them would be the first 3 characters of the string that was passed in. If you did a %-10.3s, that would give you a field 10 characters wide using the first 3 characters of a string, but it would shove them over to the left side. They would be left justified because of the dash. So the precision in a string says the maximum characters of the string to be printed. Now, if this is for a float, an F in here, like here, %7.2 float, this says that there will be 2 numbers, like currency, 2 numbers to the right of the decimal point of the floating point value will be printed. So here %7.2 means in a field 7 wide, you may put 2 digits to the right of the decimal. Now that doesn't mean 7.2. You're not going to have 7 and then a decimal point and then 2. You're going to have 7 total, which will mean 4 valid characters, a decimal point, and then 2 to the right of the decimal, okay? Because it's 7 wide. If there's an integer value that you're printing, then the .2 will be the minimum number of digits to print of the integer. So really what that means, if you have a number here that is larger than the number of digits that are in the integer, 1, 2, 3, 4, 5, however many you have in the integer, if that number is larger, it will be 0 padded to the left or the right, depending on whether you have used, again, the left justification. If you use the left justification, the integer will be shoved all the way to the left, and the right side of it will be padded out with zeros. If you didn't use the dash, then it will go to the right justification, and it will be padded to the left with zeros to fill out the maximum size of the field. And in this case, this is a 7.2 float. Okay, minimum digits of an integer.